So very good afternoon. Today we will see various architectural classification schemes. As you know that computer can be classified in several ways. The way in which it is not possible to divide human being in different categories. There may be appearance one category, marks second category. How you can divide the persons in different categories? That is a very difficult task. Similarly, dividing the computers in different categories is a very difficult task. And therefore, because there may be several parameters, speed, memory, and various other parameters. So scientists have always attempted to divide the computers in various categories in a very effective manner. And in this process, there are three architectural classification schemes for computers. That means computers can be divided into different categories in three according to the different scientists, and one is Flynn's class called Flynn's classification scheme, second is called Frank's classification scheme, third is called Handler's classification scheme. And Flynn's classification scheme came in the year 1966. Frank's classification scheme was given by scientist Frank in 1972. Handler had given a classification scheme in the year 1977. So Flynn's classification scheme is based on instruction and data parallelism. As I told that computers can be classified in different manner on the basis of different things. So Flynn's classification scheme divides the computers in different categories on the basis of instruction and data parallelism. Frank divides the computers on the basis of serial and parallel processing. Handler's classification scheme is based on degree of parallelism and pipelining. Somehow, Flynn's classification scheme has become most popular, and therefore, in today's session, we will discuss Flynn's classification scheme in detail. So, according to Flynn's classification scheme, computers may be of four types: SISD, SIMD, MISD, MIMD. SISD means single instruction stream, single data stream. I will tell you shortly what is the meaning of stream. Anyway, SIMD means single instruction stream, multiple data stream. MISD means multiple instruction stream, single data stream. MIMD means multiple instruction stream, multiple data stream. So this is given in the books of 32 bricks, page 11 Kaiwan. You can refer for more details. So SISD is, that means in SISD there is no parallelism involved. In SIMD there is data parallelism. In MISD there is instruction parallelism. In MIMD there is instruction and data parallelism both. So SISD, example of SISD is uniprocessor and or all conventional sequential computers. That means ordinary desktop computers, ordinary computers, PC, personal computers over which we daily work. That is under the category of SISD, and that is a uniprocessor machine. This thing is written on page 11 Kaiwan. In SIMD category, vector and array processors are there. Vector and array processors. MISD, instruction parallelism is implied in MISD, as I told earlier also, and instruction parallelism, note down, instruction parallelism is used in RISC, reduced instruction set computing, CISC, complex instruction set computing, VLIW means very large instruction word computers, and systolic arrays. But as such, I will tell further also that MISD, that means no practical computer exists in MISD. This is only for theoretical purpose. And MIMD, so instruction and data parallelism both are employed, and all parallel computers, supercomputers which we call fully parallel computers fall under the category of MIMD. So I think it is clear. Under SISD, all uniprocessor or conventional sequential computers. Under SIMD, vector and array processors. MISD is no practical computers, but in instruction parallelism is employed in this MISD, and all RISC-SysLiu architectures and systolic array follow instruction parallelism. But this does not mean that RISC, sys, etc. are MISD. No, RISC, SysLiu computer or systolic arrays are not the examples of MISD. These are the examples for instruction parallelism only. This is coincidence that instruction parallelism is used in MISD also. But this does not mean that RISC, etc. are under the category of MISD. And all fully parallel computers, supercomputers, are in MIMD category. So I told that I will tell you what is the meaning of instruction data stream. So first of all, let us understand what is the meaning of a stream. A stream means sequence of items or elements. Just like train, in which there are various bogies one after other. A stream means sequence of elements or items. So instruction stream means sequence of instructions. Data stream means sequence of data. And this is written on page 32 bricks. Bricks and Kaiwan are the two books which are used worldwide and are the most fundamental books in the area of parallel computing. So in the book of Hayes, page 543, this very good diagram is given. Processor P and memory M. Memory means RAM, not hard disk, etc. RAM, temporary memory. So instruction stream is coming from memory to processor. Instruction stream means several instructions one after other. And processor is taking data also from memory. This arrow is showing that from memory to processor data is coming. Data stream means various data. And then processor is processing or executing the instruction and writing the result back in the memory. And therefore you can see that there is two directional arrow here, but here there is only one directional arrow. That means instruction is being taken from memory into the processor. Processor is taking data, processing, and then writing the result back into the memory. So popularity wise, SISD, ordinary, I told that SISD, that means ordinary PC computers, personal computers. So this is most popular. Then MIMD is second number. Then SIMD and MISD is least popular. This thing is given on page 11 Kaiwan, that MIMD, SIMD, MISD. But I have written added from my side that SISD is most popular. So MIMD means fully parallel computer. So now I am going to explain about SISD, MISD, SIMD, MISD and MIMD working of these in short. So from CSI Communication, Computer Society of India Communication Magazine, October 2003. October 2003, page number 6, I have taken this diagram, and in this it is given that SISD means single instruction, single data stream. Single instruction stream, single data stream. For example, plus and AB, and these are two things added, A plus B. Single instruction, single data. Instruction is plus, data is A and B. SIMD means single instruction, plus is single instruction here, and multiple data. That means A, B and C, D are multiple data. So same operation is performed on multiple data. Therefore, A plus B and C plus D are coming out of SIMD. MISD means multiple instruction. See there. plus and into, these are the two multiple instructions. Plus and multiplication, these are the examples of multiple instruction. And single data, AB. Here I should have written CD also, but it is not written here by mistake. So you can write it down CD also. So uh, sorry, multiple instruction and single data, this is correct. Here it should be A into B. That means multiple instruction is performed on single data. Plus and multiplication are performed on A and B only. Plus and multiplication are performed on A and B only. This is single data, and plus and into are the two operations, instructions over same single data. So result should be A plus B and A into B. You convert it into A into B. This should be A into B, not C into B. Okay, plus is performed on AB, then multiplication is performed on AB. That means multiple instruction is performed on single data. And MIMD means multiple instruction. Plus and multiplication are multiple instructions. MD means multiple data. AB and CD are multiple data. So plus is performed on AB, multiplication is performed on CD. So A plus B, C into D. So in SISD, single instruction, single data. SIMD, single instruction, multiple data. MISD, multiple instruction, single data. MIMD, multiple instruction, multiple data means two instructions and two set of data. So this is very wonderful diagram which was given in this magazine, and nowhere in the book etc. it is given. So I have taken it. Now let us come on actual diagram of architecture of SISD, SIMD, MISD, and MIMD. So this is taken from the book of BICS, page 33 BICS. CPU can be divided in three parts: control unit, processing unit, and memory module. You know that control unit, ALU, arithmetic logic unit, and memory unit are the three parts of CPU. But ALU is called here processing unit. Processing unit PU is same as ALU, and memory module means there is one memory which is divided into various small modules. So this is means memory module. So this is control unit, this is processing unit, this is memory module. All three are the parts of one CPU. So here you can see that one direction of one unidirectional arrow is coming like this in control unit. Control unit is taking instruction from memory. This is called load operation. That means instruction is loaded into the control unit. Then control unit decodes the instruction. Decoding means identifying the resources. So that means where to perform, how to perform that particular instruction. That is called decoding. So control unit decodes the instruction and gives this decoded instruction to the processing unit, that is ALU. So see, unidirectional arrow is coming here. Note it down, not double direction. This is called decode operation. Control unit gives decoded instruction to the processing unit, and then processing unit takes data from memory. Data from memory. This is called fetch operation. FETCH, fetch. That means suppose 2 plus 2 is to be done. So plus is coming here, and then PU processing unit is taking 2 and 2 here, and then plus operation is performed and result is written back into the memory. That is called write operation. That means result is written back into the memory. Therefore, you can see that between PU and MU there is double-sided bidirectional arrow. Data is taken from memory to PU, and data is that means result is written by processing unit into the memory. That is called write operation. This is SISD. SIMD means single instruction stream, multiple data stream. This is MM1, MM2 up to MMM, not N, MMM. Control unit, processing unit, memory module, instruction stream, data stream. So you can see that Memory is divided into various memory modules, MM1 to up to N, and instruction is taken from memory to control unit, that is called load operation, as I told here also, and this instruction is decoded by control unit, and this decoded instruction is given to different processing units. That means the same instruction is given to different processing units or ALUs. SIMD, you can understand it as your laptop, dual core, quad core, octa core laptops. This is also the example of SIMD. Single control unit is there, one control unit is there, but various cores are there, or various ALUs are there, or various PUs or processing units are there. All are same. So same instruction plus is performed on different data. SIMD, single instruction, multiple data stream. So data is fetched or taken from memory into PU processing unit 1 to data it is fetching. For example, this PU2 is fetching 3 and 3 mm and PUN is fetching 4 and 4, for example. So same instruction, that is plus, will be performed on all data. So processing unit 1 will write 4 back into the memory, processing unit 2 will write 6, processing unit N will write 8, etc. In this way, result will be written back into the memory. This is the example of SIMD. That means same instruction is loaded, decoded, and decoded is same instruction is given to different processing units. Then data is fetched from memory into the processing units, and result is written back into the memory. That means single instruction stream, multiple data stream, DS1, DS2, DSN, etc. But IS, same single instruction stream. Now MISD, this is shared memory module, as I told earlier, that a big memory is divided into various modules for convenience. MM1, MM2 memory modules. These are shared memory modules. So this control unit 1 is taking instruction 1 from this memory, like this. Control unit 2 is taking instruction 2 from memory. Control unit N is taking instruction N from memory, like this. Then all are decoding. Control unit 1 is decoding and is giving IS1. That means, for example, plus here into processing unit. Control unit 2 is giving IS2 single. That means second instruction is streamed to processing unit 2. Control unit N is giving ISN to processing unit N. Because there are multiple control units and multiple processing units. In SIMD, there was one control unit, multiple processing units. In MISD and MIMD also, there are multiple control units and multiple processing units, you can see. So different instruction streams are taken, multiple instruction stream. That means multiple instructions are taken by multiple control units. Then these are decoded and are given to the processing units. Processing unit is taking single data stream. See, only single data stream which is coming into PU1. Then whatever operation was required, that was done. For example, 2 are coming. Then plus operation will be performed. 2 and 2 will be added 4. Suppose after that multiplication or minus or whatever square is to be done. Then PU2 processing unit P will perform next operation on same result. Output of processing unit 1 is becoming input of processing unit 2. Output of processing unit 2 will become input of processing unit 3. In this way, there is a pipe and same data is flowing and different instructions are getting performed. And then result is going and final result will go back into the written into the memory. This is MISD. Now coming on MIMD. So as I told earlier, multiple instruction stream, multiple data stream. There are various instructions over various data. There are various control units, various processing units. This is shared memory module, which is divided into memory modules 1, 2, etc. And then control unit 1 is taking the instruction from memory, and it is IS1 which is coming into control unit 1. Instruction stream 2 is coming into control unit 2. Instruction stream means sequence of instructions, that means various instructions, not one instruction. Stream means various instructions. So various instructions are coming into control unit 1, various instructions are coming into control unit 2, and all instructions are coming from memory. So control unit 1, 2, 3, etc. They are decoding these instructions and giving these decoded instructions to processing units 1, 2, 3, etc. Processing unit is taking or fetching the data from memory. Suppose PU1 is fetching 2, 2, PU2 is fetching 3, 3, etc., 4, 4, etc. So suppose plus operation was there, here minus operation was there. So 2, 2, 2 plus 2, 4 will be written back by processing unit 1. Then 3, 3 data is taken by processing unit 2, and control unit 2 is giving minus. So 3 minus 3 is equal to 0 will be written in memory. Similarly, this PUN is taking 4, 4 from memory, and from here this multiplication is coming, that means as is instruction, and therefore 16 will be written. So this is all about SISD, SIMD, MISD, MIMD. This is Flynn's classification scheme. Now, what are the example computers which exist all over the world? So under SISD, as I told, all personal computers are there, but still for example computers, as I have taken this from page number 34, BICS with one functional unit. This is the example IBM 701. SISD with multiple functional units, IBM 36091. This is very, very famous computer, IBM 36091. There are multiple functional units, but still it is under the category of SISD. In SIMD, there may be two categories: word slice processing, bit slice processing, and ILIAC 4 is the example of SIMD under word slice processing. MPP and one more is DAP, etc. are the examples of SIMD under bit slice processing. As I told earlier, under MISD, there is no practical computer, falls in this category, and this is written on page number 34, BICS also. Therefore, in the world, there is no actual computer which belongs to this category. This is only for theoretical purpose, MISD. MIMD, in MIMD, there may be two categories: tightly coupled, loosely coupled, and Cray XMP supercomputer is under the category of tightly coupled MIMD. Univac 1180 is under the category of MIMD, loosely coupled. So this is all about Flynn's architectural classification scheme, which I told today in today's lecture. This is the most important classification scheme and has gained most popularity all over the world. So thank you.
Thank you, sir.